Right, we're continuing on with our section. We're looking at right angles, and I have some questions for you. The first is this. Is it true that the angles of a right angle, here they are, two angles of around the perpendicular line, is it true that they are never equal? Or is it false? Right, a perpendiculum is a plumb line, also called a lead line. Is it used to check that things are dead upright? Is that true or false? Is it used to check that things are upright? Is it true that a perpendicular angle is the same thing as a right angle? Does the Latin rectus mean at an angle, or does it mean at a right angle? Is a right angle right because if you build a building, the wall is nice and straight and upright? Are the angles on each side of a perpendicular equal? The next thing I want you to do is draw a straight line in your book. Draw a straight line. And then using your set square, which looks like this. This is your set square. Use the set square to draw a line that's perpendicular to the one you've just drawn. Because what you have to do is put your set square on the line so that one side of it is touching it. Make sure it's touching it as well as you can all the way down. And then you draw your perpendicular. There it is. Like that. Now, this angle here is a right angle. Any angle that is sharper than this is called a sharp angle. And any angle that is more blunt than this is called a blunt angle. So, in Latin, the word for sharp, right, acutus. Acutus means sharp. And so, we take this and make it into English, and we turn it into an English word, which is acute. Which means sharp. So, for example, here I'm going to draw, for your pleasure, a spear. And let's make the spearhead. There it is. There's our spearhead. Now, this spearhead has got an angle, and this is an acute angle because the spear is sharp. If I were to make a spear like this, well, here's my spear. Right, which of these two spears are you more scared of? This one or that one? It's obvious that if somebody thrusts or pushes this one into your body, it'll go in much more easily than this one. Yes, this one will make a hole, but you have to push it much, much harder. This here is acute or sharp. So an angle that is acute is an angle that is sharp. So anything that is less than 90. So here's 90. Any angle that's less than that, for example, this angle here, that is an acute angle. Or here we have now 1, 2, 3 acute angles. Right, these are all acute angles, and we can add more of them. 1, 2, 3, 4 acute angles. Right? Each time we make them more and more acute. The more we divide it, the more acute they get, the sharper they get. So that's an acute angle. In English we use this word acute, sharp, for lots of different words. For example, if you have a very acute mind, if your mind is acute, that means you are very sharp, you are very clever. Right. This here, this drawing, the blue and red one, it has 2 right angles. Right, where are they? Where are the 2 right angles in this drawing? Right, they're here. We have one here. By custom, we put a little box in it to show it's the right angle. We put a little box here to show it's the right angle. Right, all other angles, we don't use a box. We use a little curve. So we put a curve here if it's not a right angle. We put a curve here if it's not a right angle. Right, that's not a right angle. We put a curve. This is not a right angle. We put a curve. Okay. But if it's a right angle, we put a box to show it's the right angle. So there are 1, 2 right angles, and of course they are equal. They're the same on this side as on that side. That's what this symbol means. This symbol means that whatever is on this side here is the same as what's on that side. So this is the same as that. Now, an angle that is the opposite of acute isn't sharp, it's blunt. And in Latin, this is obtusus, which means blunt. We also use this word talking about people. If you tell someone, don't be obtuse, that means they should get to the point, right? They should be more acute. Someone's being obtuse isn't telling you something very clearly. It's like listening to, sometimes people try to explain something and it's very, very unclear. Or they're being obtuse. They're not getting to the point. So we have the opposite of getting to the point. The opposite of being acute is being obtuse or blunt or unclear. So let's draw an obtuse angle. I'll draw it here. Here it is. Nice obtuse angle. Right, that is an obtuse angle. It is not sharp. Right? Here's an acute angle. There's an acute angle, nice and sharp. So what I want you to do in your books right now is draw an obtuse angle and draw an acute angle. Right, a plane is a flat surface, and we can show the plane by drawing a straight line. Right? It's a surface, however, remember, not a line. So in reality, it's going off like that into the distance, right? There's our flat surface, like that. If we place 2 flat surfaces one above the other, and we can do that by using the 2 sides of the ruler. There we go. 2 flat surfaces, one above the other. So let's see, like so. Right, these 2 surfaces are one above the other. And just imagine that they didn't actually have any edges. I've drawn edges around them, but imagine they just keep on going out that way and that way forever and ever and ever. Right? If I hadn't drawn the edges, you wouldn't be able to see them at all. But imagine they're going forever and ever. Then, because they are equal distances from each other, right, at all points, they're always equal distances. The distance is the same here and here and here. That means they will go away from each other forever and ever and ever, and they will never, ever, ever, ever touch. Right? They will never touch. And it doesn't matter if I do two straight lines or if I choose to make two curved lines. For example, if I were to do this, there are two parallel curved lines. Like so. And if I were to imagine that these were curved surfaces, right? Like so and like so, right? They are the same distance apart here as here, right? And they're the same distance apart wherever you look. So if I was to imagine these two curved surfaces going forever and ever and ever, right, of course they would meet around the other side because they're curved, but they will never touch. Right? These surfaces, the one will never touch the other, no matter what happens. Now, these surfaces, we say that they are parallel. That means that the one is opposite the other and they never touch. So I wanted to draw two parallel lines. The easiest way of doing that is to get your ruler and use each side of a ruler without picking a ruler up like that, right? That's the quickest way to get two parallel lines. Well, you didn't even get one of them there because my pen is not working well. Let's change to a nice thick pen. So two parallel lines, 1, 2. These lines are parallel. They are equal distances apart, and if I was to stretch them out forever, the two lines would never meet. I can also make two parallel lines that are curved. If I stick my compass in, making sure that it goes into paper nicely, I make one line like so, and then I change the angle of the compass and make another line, keeping the point in the same hole. So the point is in the same hole, and I make another line. Then I have two parallel lines. You can just see them here, right? I'm going to go over them in red. There's one. There's the other. So we have two parallel curved lines, which, if I had done them perfectly, would be the same distance apart everywhere, and they'd go forever around and round, one circle inside the other. I wanted to draw two parallel curved lines and two parallel straight lines, and the word is parallel. Parallel, spelled like that. Another Latin word. The Latin word we're going to look at now is vergo. Vergo. I'll write it out for you. We say it in the English pronunciation, vergo. So in the old way that we used to say, pronounce Latin in England, vergo, it means I bend or I turn. So vergo means to bend or to turn, and con is a Latin word which is used in lots of English words. It's a bit of a particle that comes at the start of words, and it means together. So con means together. And verge means to bend or to turn. So if we have two lines that turn together. There's one coming in like that. And the other line is turning together with the other one. There they are. They are turning into each other. They're not really bending, but they are moving in towards each other. And we say that they are converging towards the right. So we write this like so. Converging towards the right-hand side. So what does the word converge mean? And also, I want to draw a letter B, write a letter B on your page in your book, and draw two lines that converge toward the letter B. Right, if you did this correctly, you would end up with two lines coming in from any direction, doesn't matter which direction you bring them in from. They're coming in towards the B, and they're converging towards the B. The next little Latin word we're going to look at is dis, D-I-S, and dis is the exact opposite of con. Dis means apart or not together, as in disconnect, right? So it means apart. It means not together. And so we have disverge, but this is not good English. Disverge. And what happens is that the S here disappears. It goes away. And we end up with diverge. Right? Diverge. So we dislocate our elbows, right? That means the location, the place is apart, right? The elbow, we can dislocate a finger joint, right? It's moved apart from its location, from its place. And we can dissolve the salt, right? We put the salt in the water and it breaks apart in the water, right? So let's do a letter B here. Make a B on your page. And I want to draw two lines diverging from the letter B. Right, if you did that, what you should have ended up with is something like this. Two lines diverging from the letter B. Because they are moving apart. They are not together. Right? So they are turning apart or moving apart from B. Another Latin word. As you can see, learning maths and geometry, understanding it, a lot of it comes from the language. If we understand the language, then the maths is actually quite easy. Equi. Right? Equi is Latin, and it means with the same everywhere. Right? The same in all parts. And it gives us a number of English words. It gives us the English word equal, right? Equality, equalness. The word latera we've seen already before. It means a side. And if latera are sides, equi means with equalness, then what would this word mean? What do you think that word might mean? Equilateral. And of course, equilateral means having the same length sides. So different shapes can be equilateral. We can have a triangle that is equilateral. For example, we can make an equilateral triangle. Now, I'm doing this just by eye, so the chances are that I'm not going to get it quite right, but we have a way of showing you that it's meant to be equilateral even if it really isn't. So this probably needs to be a bit longer, so probably a bit more like that, and we're getting closer to equilateral. There is a better way of doing this, that's geometrical. What we do to show that it's equilateral is we put an equal sign on each side. We put an equal sign here, an equal sign here, and an equal sign here, and that shows us that we mean, even though they're actually not drawn the same length, we mean them to be the same length. And we say that this triangle is therefore equilateral because all the sides are the same length. So why is this triangle said to be equilateral? Right, I want you to do something now. I want you to draw a stick figure. Draw a straight line on the bottom of the ground like that, and draw a stick figure. Give him quite nice big legs. And there, little stick figure. Right. I want you to draw him in your book. Make sure that you use straight lines for his legs. Right, this is important. This is a geometrical stick figure. Straight lines for his legs. Now, when you stand up, we've pointed this out before, there's a triangle between your legs. You can see it right there. Now, if you are in good health, both your legs, this leg here and this leg here, are the same length. And so we can put an equal sign here, and we can put an equal sign here. And we have a special kind of triangle here, one that has two legs that are the same length. The third side that's on the floor, unless you're standing with your legs really widely apart, which we don't normally do, is shorter. So I want you to copy this man and put the equal signs onto his legs. So let's move on a little bit. We've just drawn our man with equal legs, and we have a Greek word. Now, I'm not expecting you to learn Greek. I'm just writing it up here for a bit of fun. And the Greek word is isosceles isosceles. Now, this word isosceles means iso means with the same. So iso means with the same. And we have this word, for example, isometric means with the same measurements. So iso is a Greek word meaning with the same. In other words, it's the Greek word for equi. Right? So iso is the same thing as equi, but it's a Greek word. And skeles is legs. So this actually means equal legs. Now, if we remember, earlier on, we were drawing our angles, and we called the lines that lead up to the vertex legs. Remember that? I wrote the word leg here. And here's our vertex. Now, if we make a triangle with equal legs, for example, this one is going to be 10 centimeters long, and this one is going to be 10 centimeters long, so they are equal legs. Okay, we put our equal sign here, equal legs, and we put the third line here to make it into a trigon or triangle or trilateral. There it is. We now have what's called an isosceles triangle, or if we pronounce it in the Greek way, isosceles, right? Isosceles. Isosceles triangle, equal legs. There it is. It's a special kind of triangle. What I want you to do is, in your book, draw an isosceles triangle. Now we have another Greek word which comes into Latin as scalenus. Scalenus means not having equal lengths. In other words, it's a geometrical word invented by the Greeks to describe a triangle where every side of it has a different length. For example, let's say this side of the triangle is 10, and this side of the triangle is 15, and this side of the triangle is 19.5. So they all have different lengths. So this side, which we'll call A, and this side, which we'll call B, and this side, which we'll call C, are all unequal. And so we have what we call in English a scalene triangle. Right? One with unequal lengths of the sides. So I wanted to do the following things. 1, I wanted to draw a scalene triangle. 2, I wanted to draw an equilateral triangle. And 3, I wanted to draw in your book an isosceles triangle. Now with a triangle, if a triangle has a right angle, let's make one like so. I'll put it on its side. Let's start off with our right angle. There it is. Then we say it is a right-angled triangle. There it is, and it has a right angle. Remember that to mark the right angle, we put a little box in the corner to show that this angle is intended to be a right angle. There's our right-angled triangle. Obliquus. Let's write this word down. Is a Latin word. And this Latin word means slanted. That means slanted. Like a ramp that leads up, like a wheelchair ramp is oblique, it is slanted. A wall that is not straight is oblique. So this word obliquus means wonky. Right? It means wonky. So a triangle that does not have any right angles in it is a wonky triangle. So let's make one. We have two kinds of triangles. We have right angled triangles and we have wonky triangles. Let's make a wonky one. Not hard to make. All you have to do is avoid a right angle. And there we have a wonky triangle. Right? It does not have any right angles in it anywhere. Right? This angle is more than 90. We can make one that's even more wonky. Here's a very wonky triangle. Right? So these triangles are called oblique triangles. Let's write this word down. Oblique. Right? They are at a slant. They are slanty. They're slanty triangles. And that's it for triangles. The next section we're going to talk about quadrilaterals and various kinds of quadrilaterals.